in this example, I wanted to again show you why the second derivative test can be really useful when we're finding when we're doing maxes and mins, especially with implicit differentiation. So if I find the derivative here, the derivative of x squared is 2x. The derivative of y cubed is 3y squared dy dx. And the derivative of 9 is 0. Okay, let me do all my algebra right here. I'm going to subtract 2x, divide by negative 3y squared. So my derivative is 2x divided by 3y squared. Like that. Now, to find the spot where there is a horizontal tangent. Well, let me just remind you here, to make a horizontal tangent, we need the derivative to be 0. Okay, I'm just going to write horizontal tangent dy dx is equal to 0. Well, really, though, we're only concerned with making the numerator 0, because if I made this 0, 0 divided by anything is 0, and I've done it. If I made the bottom 0, then I'm making the derivative undefined. I don't want to do that. I want to make it 0. So all I need to do is focus on the numerator. 2x equals 0. Well, that means that x is equal to 0. Now, in implicits, I should also get y. Okay, so I'm going to go back here to the original. Let me just, can I draw an arrow down here? I know x is 0, so 0 squared minus y cubed is 9. Well, that means, of course, 0 squared is 0. So I could do a little algebra here. I have y cubed equals negative 9. So y is the cube root of negative 9. So now I know that x is 0, and I know that y is the cube root of negative 9. Okay? So now I've got that point. And by the way, the cube root of negative 9 is just a little more, or a little less, I guess, than negative 2. Negative 2 point something. Well, now, if I want the second derivative to classify this, because, of course, I don't really have a way of putting that point on a number line like I do when it's just an x, when I just say, oh, it's x is negative 1/2. That I can easily put on a number line and just plug x's into the derivative, but I have trouble doing that with a second, or with an implicit. So let me find the second derivative. We've got low d high minus high d low cross the line and square the low. Now, I'm going to just, kind of get my way through this by using positives and negatives. Okay? And you'll see why that works. Of course, there are times you actually plug it in your calculator, but we have kind of this little key up here where we say, well, x is 0 and y is the cube root of negative 9. And also remember that dy dx is 0. I mean, that's how we set this up. We wanted a horizontal tangent. So we've got in our derivative y's, which will make the cube root of negative 9. We've got x's, which will make 0. And we've got dy dx's, which will make 0. So if I do that, 3 times a negative squared times 2, this whole thing, I'm just going to put a plus here, this whole thing is positive. Okay. Now over here, 2 times 0, 6 times y times 0, this entire thing is 0. And the denominator, 3 times a negative squared, and then squared again, this is absolutely positive. So in my second derivative, I have a positive minus 0 divided by a positive, which means I get a positive. So the second derivative is greater than 0. So the graph is concave up. If I tell you that something is concave up at its critical point, think about the shape of concave up, right? Here's concave up. It must have a minimum. Okay. Let's check with the graph. Okay, remember the point is when x is 0. So here's the graph, and you can see that we do have a minimum when x is 0 and y is the cube root of -9, which is just, negative 2 point something. So you can see we have a minimum there. The one other thing I wanted to mention, my derivative was this. And I was really just focusing on the numerator before. Remember I said I wanted the derivative to be 0, so I set 2x equal to 0. Well, if I set the bottom equal to 0, of course y would have to be 0. When I divide by 0, when I have a number divided by 0, I get something that's undefined. So when y is 0, dy dx, which remember is the slope, is undefined. Okay, because I'm dividing by 0. Well, look at when y is 0, what happens? I have little vertical tangents. So I have an undefined slope at those spots. So the implicits tell us a lot of things. Finding where the numerator is 0 tells us where the horizontal tangents are. Finding where the denominator is 0 tells us where the vertical tangents are.